Unit 4.2 Quadratic Equation in Standard Form. In Unit 4.1, we learn vertex form, which is y equal to a parenthesis x minus h squared plus k. This is the vertex form. And in this unit, we're going to learn the standard form, which is y equal to ax squared plus bx plus c. So the class objective of this unit is to graph quadratic functions written in standard form. In other words, given a standard form of a quadratic function, you can sketch the graph. Two important things you have to learn in this unit is to learn the features of quadratic function, which are, of course, the vertex, the y-intercept, and the axis of symmetry. We also have to learn how to convert a standard form to a vertex form, which is we change y equal to ax squared plus bx plus c to ax minus h squared plus k. Now let's take a look at the properties or the features of quadratic functions in standard form. First, whenever you see the exponents of the x is equal to 2, which means square, you know the graph has to be a parabola. So it's either this one, like this, open upwards, or gonna reflect across the x-axis, become open downwards. Let's go back to the vertex form a little bit first. Remember, we have y equal to a x minus h whole square plus k. So if this is a positive sign, that means a is bigger than 0. We know the graph is going to be open upward like this. But when a is negative, we have a negative sign here, then we know it's going to be a reflection across the x-axis, and then it becomes open downward. Or you can say a is less than 0, which gives you a negative value of a. Next, this is something new that you have to learn in this unit. For the axis of symmetry, for parabola, it is equal to minus b over 2a. For example, if you have 2x squared plus, say, 8x plus 5, so the axis of symmetry, which is its equation of line, it has to be x equal to negative, in this case b is plus 8, so negative b is going to be negative 8 over 2 times a, in this case is 2, so we got negative 8 over 4, which is negative 2. So the axis of symmetry in this particular quadratic function is x equal to negative 2. The next feature of quadratic function in standard form is the vertex. In vertex form, we know the vertex right away from looking at the function. In standard form, we have to do a little bit calculation here. So the x coordinate of the vertex is negative b over 2a. It is exactly the same thing as the axis of symmetry. The axis of symmetry is a line, and here we're talking about the coordinate of a point. You will understand what I mean if you look at the graph here. Look, the red dotted line here represents the axis of symmetry, which is x equal to negative b over 2a. In other words, every single point here, of course including the vertex, the x coordinates of all these points are all negative b over 2a. Now that you know the x coordinate of the vertex is negative b over 2a, the question right now is, how do you find the y coordinate of the vertex right here? It's very simple actually. Before I do that, I just show you one example. If you have a linear equation of y equal to x plus 1, or you can rewrite as fx equal to x plus 1. Now say if you know x is equal to 2, all you need to do just plug back the 2 into the original equations, so y is going to be equal to 2 plus 1, which is equal to 3. Same thing here, since you know the x-coordinate of the vertex is negative b over 2a, so all you need to do is just do f of negative b 2a, then you can find the y-coordinate of the vertex. In the next slide, I'm going to show you an example of how do you do that. It will make it clear for you to see. Before we do that, we still have one more feature of quadratic function that we have to cover. That is, the y-intercept of the quadratic function in standard form is actually 0, c. In other words, if you have a quadratic function set up like this, say y equal to, or f of x equal to 3x squared plus 4x plus 5, you know right away the y-intercept is going to be the c value right here, which is 0, 5. Here's the example. What is the graph of y equal to x squared plus 2x plus 3? First, we try to identify what a, b, and c are in these quadratic functions. If you line them up, let me give you this line up right here. Y equal to ax squared plus bx plus c. So right away you know c is equal to 3 right here, c equal to 3 right here, b equal to 2, and a, without anything in front of x squared, it is a 1, so a equal to 1. According to the formula, the axis of symmetry, remember, is a line, which is equal to x equal to negative b over 2a. By doing a little math here, you know x equal to negative 1 is the axis of symmetry. So right now, if I start to graph it, I will do this. Since I know it's a parabola, and x is negative 1, say this is negative 1, this is the axis of symmetry, just like this full dotted line right here. The next thing, I try to find the vertex. I know the x-coordinate is actually the same value of the line of symmetry, which is negative b over 2a or negative 1. I know the x-coordinate of the vertex right now is negative 1. The question is, how do we find the y-coordinate? All we need to do is, we have f of negative 1, which is equal to, we plug in negative 1 back to the original equation, which is x squared. Now x I'm going to change to negative 1 squared plus 2x is negative 1 plus 3. So if you cannot see clearly, I just put it up here to let you see. So x squared plus 2x plus 3, which is the original equation. All I did is just change the x values to negative 1. So if you evaluate them, it's equal to 2. The vertex right now is, this is the y coordinate of the vertex. So by putting this one back to here, which is 2 right now, the vertex is negative 1, 2. Negative 1 over 2 is the vertex right here. We also know the y-intercept is 0, 3 because the c value is 3. So we know the y-intercept is right here, which is 3. And we just need one more point, the reflection of 0, 3 right here. Because they are symmetric, if this is a distance of 1, I know this is going to be another distance of 1 right here. That's why I have negative 2 and 3. By connecting all these dots, we come up with the graph right there. Now that we know the vertex, we can actually rewrite this quadratic function in standard form to vertex form. Since the vertex form is y equal to a x minus h whole square plus k, where h and k is the vertex, and we also know a is equal to 1 right here, so y equal to 1, h is negative 1, so we have x minus 1, be really careful on this one, square plus k is 2. So the vertex form of this quadratic function is 1, times x plus 1 whole square plus 2. Of course, we can take away the 1 here, so x plus 1 whole square plus 2. The last challenge of this unit is the question like this. You're given a parabola which has a vertex here, and this parabola passes through this point. Since it's a parabola, you know right away this is a quadratic equation. So the quadratic equation in vertex form is y equal to a x minus h whole square plus k, where h and k is the vertex. The reason you use vertex form because they give you the vertex. So by substitute all these values back, you're going to have y equal to a times x minus 2 whole square plus 7. We didn't get the equation yet because the variable a is unknown. You always have x and y in the generic formula for vertex form, so we need to solve for a. Since they give you this point which the graph passes through, that means if you plug it in back to these equations, it will make this equation come true. So all we need to do is plug in 4 for x and 6 for y. So here we are. We have a new equation right here. 6 equal to a 4 minus 2 because x equal to 4 whole square plus 7. So let's solve it. First, we're going to simplify the parentheses, which will give us 2 squared plus 7 right here. So we isolate a by subtract 7 on both sides, which will give us negative 1 for a. We divide by 4, divide by 4, so a is equal to negative 1 over 4. Once we have the a value, we can write the whole equation in vertex form. Y equal to a, which is negative 1 over 4, times x minus h is 2, and plus k is 7, is square here of course. And that's the quadratic equation in vertex form. Now they ask us to graph it. So I will do the graphing right here. Let's start with the parent function, which is y equal to x squared. So the first movement here is 2. So it shifts to the right by 2 units. I'm going to change the other color to show it to you. So I use blue. So the first movement is shift to the right by 2. So the problem represents y equal to x minus 2 squared. The next transformation is for 7. This represents a translation of 7 units up. I'm going to do this green right here, then on scale. Okay, so 7 is right here. So the green represents y equal to x minus 2 whole square plus 7. The next transformation is 1 over 4. Since it's less than 1, it is vertically compressed. So the vertex is not going to be changing. So the shapes of the curve is going to be changed. This is y equal to 1 over 4 x minus 2 whole square plus 7. But the transformation is not done yet because we still have negative sign here. It means a refraction across the x-axis. So finally, the graph is going to be like this. Reflect across the x-axis. So this is y equal to negative 1 over 4 x minus 2 square plus 7. So the transformation involves a shift of 2 units to the right, translate up 7 units, and vertically compress by, I don't have enough room here, a factor of 1/4. Now of course the last one is the reflection across x-axis.